Hi everybody, and welcome to the video on section 10.2. This is a video about simple interest. So in the financial world, there are two kinds of interest. There is simple interest and compound interest. Simple interest is the subject of this video and section 10.2. Compound interest is the subject of 10.3 and 10.4. Simple interest does not occur nearly as often as compound interest does. In real life, you will encounter compound interest far more often. However, to understand compound interest, you must first understand simple interest, and there are certain financial instruments like government bonds that do run on simple interest. So short-term loans and things like government bonds will run on simple interest. So we will define what simple interest is and then look at examples like that. To begin with, let's start with some terminology. Money has both a present value and a future value. So unless you're lending money to a friend, if you invest P dollars today for a promise of getting F dollars at some future date, you would expect F to be more than P. Right? So if I'm going to invest $800 today and then get a payment back in 2 years, I would certainly expect to get more than $800 back. Otherwise, I wouldn't have invested that $800. So that $800 is called the present value. It's what the money is today. And the future value, what the money will be worth in 2 years, 3 years, whatever, that is called the future value. So if I loan you 20 bucks and I'm expecting you to give me back 25 bucks in the future, $20 is the present value and $25 is the future value. The same principle we just discussed works in reverse. If you are getting a present value of P dollars today from someone else, either in cash or in goods, you expect to have to pay a future value of F back at some time in the future. If the bank, for example, gives you a loan, you are expecting to have to pay a future value of that money back sometime in the future. The main question of this section and section 16.3, actually, is if we are given a present value P, how can we figure out how much that money will be worth in the future? And vice versa. If I give you a money amount in the future and ask how much money would it cost now to obtain that amount, you should be able to do that as well. So getting a present value from a future value and vice versa. The answer to the previous question depends on several things, but the most important factor on which that answer depends is the interest rate. Interest is the return the lender or investor expects as a reward for the use of his or her money. So if I'm going to lend you 20 bucks, you're not just going to give me 20 bucks back. Unless I'm being extremely friendly to you. I'm expecting some sort of payment on top of the money I give you as sort of a fee for using my money. So if you like, interest can be thought of as the fee somebody charges you for the use of their money. The standard way to describe an interest rate is as a yearly rate, commonly called the APR, which stands for annual percentage rate. So you can say things like, I am investing my money in an account that pays an APR of 5%. Or my credit card APR is 24%, things like this. So essentially what the interest rate tells you is the larger the rate is, the more money it's going to cost you to use somebody else's money. So if these are loan rates here, 5% versus 24%, you're going to pony up way more money for the 24% than the 5%, essentially. The APR is the most important variable in computing the return on an investment or the cost of a loan, but several other questions come into play and must be considered. The first question is the interest simple or compounded? Now, I'm not going to really define this word compounded until the next section, so this will be a question we'll come back to at the end of section 10.3. But basically, compounded interest, you compute interest every so often, and you keep track of all the previous interest you've gotten. And so the question is, if you're going to do that, how often do you do this compounding? Are there other fees associated with this loan or this investment or whatever? If so, are they in addition to the interest or are they built into the APR? So we're going to consider answers to these questions in this section and the following. In simple interest, only the original money invested or borrowed, and this is always called the principal, generates interest over time. This is in contrast to compound interest, where the principal generates interest, then that interest gets rolled into the principal and now generates its own interest, etc. So again, we will look at examples of this in section 10.3, but suppose that you make an investment of $1,000 and the investment is 2 years long, let's just say. Suppose that after 6 months, your investment account generates $50 in interest. If that's the case, after 6 months, you have $1,050 in your account. Suppose that 6 months later, so now a year into this investment, they're going to calculate interest again. So when they first calculated interest for you, they gave you $50. Now when they calculate interest again, they are only going to remember that you've invested $1,000. That $50 in interest that you just got 6 months before is invisible to the new interest calculation. So in other words, when you're, I'm not sure what the word is, you've invested money, so the person who's paying you back, when they pay you back, they're only remembering the amount you invested. They don't care how much interest they've previously paid you. And compound interest is different. Now when they calculate interest they will pay you, they take into account not only the original amount you invested, but also all previous interest accrued. So anyway, this will make a lot more sense by the end of 10.3, but it's something to keep in mind. Here is our first example. It's an example of a bond. Imagine that the day you were born, your parents purchased a $1,000 savings bond that pays 5% APR, and that APR is simple. The question is, what is the value of the bond on your 18th birthday? What is the value of the bond on any given birthday? So this is a more general question. So maybe you're not going to cash the bond in until you're 20, whatever. Here, the principal is the amount invested, which is $1,000, and the APR is 5%. This means, so this is an annual percentage rate, this means that the interest the bond earns in 1 year is 5% of the principal. 5% of the principal is $50. Because the bond pays simple interest, the interest earned by the bond will be the same every year. So notice this is actually the exact example I just gave you. After 1 year, you now have $50 in interest that you've earned. So the value of the bond, if you cash it out, is $1,050. But then the following year, they're going to compute interest again. They're not going to remember they paid you this $50. Okay, they're not going to take that into account. They're only going to take into account the original principal amount. So here's the value of the bond on your first birthday, your second birthday. Now we have $100 in interest. Your third birthday would be $1,150, etc. So the value of the bond on your 18th birthday is $1,000 plus the amount of time times the amount of interest, and that would be $1,900. So the value of the bond when you become T years old, so notice there's nothing special about this 18. If you replace 18 with a variable that keeps track of how old you are, the value of the bond is now this. It's the principal plus the amount of time times the interest payment. So the future value F of P dollars invested under simple interest for T years at an APR of R% is given by this formula. And this doesn't quite match what we had here, does it? Oh, no, it does. Okay, so what's happening here is you can put this P inside. So you have a P plus TRP. So the future amount can be obtained solely by knowing the principal amount, the amount of time that this thing will be invested, and the interest rate. So little r here is the interest rate as a decimal. So it's very important that you, let's see, where are we, okay, in this original interest payment calculation, we converted 5% to 0.05. So in all of these problems throughout chapter 10, you must always convert a percentage to a decimal if you're going to start using formulas. So anyway, here is the relationship between how much money you have now and how much you will have in the future based on a time amount and an interest rate. You should think of the simple interest formula as a formula relating four variables: P, the principal or the present value; F, the amount that the thing will be worth in the future; T, which is the length of the investment in years. Now, this isn't emphasized in the text here, but this is very important. You must always write your time in terms of years. So if the problem gives you a time amount in months, you must convert the months to years. So if the problem says, in 6 months, how much is this worth? You cannot use the number 6. You must use the number 1/2, because 6 months, in terms of years, is half a year. Okay, and also little r, which is the APR in decimal, not as a percentage. Okay, so given any three of those variables, you can always find the fourth one using this formula. So we'll do some examples of this, but notice if I tell you you invest 1,000 now, and it's going to be worth 2,000 in the future, and it'll be worth 2,000 10 years in the future. What was the interest rate? I've given you three of the four variables. So given three of the four, you can always find the fourth. Okay, so let's look at another bond example. Government bonds are often sold based on their future value. So suppose you want to buy a 5-year $1,000 US Treasury bond that pays 4.28% annual simple interest. Okay, so 4.28% is very high. You wouldn't be able to get that right now. But in any case, let's just take these numbers and run with them. What does this mean? When you go and buy a US Treasury bond, this number here, they're telling you how much the bond will be worth at the end of 5 years. So basically, the US government is promising you that in 5 years, you will give them this piece of paper back, and they will pay you $1,000 for it. That's what this is saying. So $1,000 is how much the bond will be worth in the future, 5 years in the future. So the question is, how much will this bond cost you right now? So in other words, what's the present value? That's the amount of money you have to pony up right now to get $1,000 in the future. So to find the present value, notice we have three of the four variables. We have the future value, we have the APR, and we have the time amount. So we'll use the simple interest formula, and let me just scroll back up to it real fast. Notice that F is 1,000, T is 5, and R was 0.0428 because we have to convert the percentage to a decimal. So that's what's written here. 1,000 in the future equals whatever I pay now times the quantity 1 plus number of years times APR. So when I do 1 plus 5 times 0.0428, I get 1.214. So therefore I have the equation 1,000 is P times 1.214. Now just isolate the P. So you divide both sides of the equation by 1.214 and you get approximately 823.72. So what does that mean? That means that you will have to pay approximately $800 now in order to get $1,000 in the future, 5 years into the future. Here's another example, a payday loan. If you don't know what these are, this is just explaining what they are. Basically, it's a short-term loan. Usually the term of the loan is 2 weeks to a month. So in other words, you borrow the money now, you must pay it back within 2 weeks or a month. So it's very short term. It's not like buying a house or something where the term of the loan is 30 years, 15 years, whatever. So a payday loan is a short-term loan in which a person can borrow a small sum, usually up to $1,500, using a future paycheck as collateral. So you walk into the store, you show them a paycheck from your work, and to like show how much money you have, and you're promising them that, hey, this I'll get this amount later, and so I can come in and pay you back. Payday loans are a big business, particularly amongst poor people. So they are controversial organizations because they are seen to prey on poor people. It is alleged that they are preying on poor people. And in many poor neighborhoods, it's actually easier to find a payday loan company than it is to find a grocery store. So, what payday loan companies say in their defense, they say, look, the people we are loaning to are risky. They have bad credit. So if we don't lend them money, nobody will. The people that we lend money to, they can't just walk into a Bank of America and get a $1,000 loan. But these people need these loans. If they didn't need them, they wouldn't take them out. So payday loan companies basically say, we are providing a service by lending to people that nobody else will lend to. But since these people are risky, right, they are credit risks, they are more likely not to pay us back. Therefore, we must charge a higher interest rate than, say, Bank of America would. So I'm not going to come down on one side of this issue or not, but be aware that these companies are seen as controversial because they are seen as preying on the poor and naive, but also be aware that they have a response to that, namely that we're lending to people that otherwise couldn't get loans, and we have to charge a higher interest rate because these people are risky. So suppose you want to go on a vacation with your buddy, you're a little short on cash, so you need to borrow $400 to get your vacation up and running. You notice that there is a payday loan company in your neighborhood, so you decide to borrow that $400 from them. This particular company charges $22.50 for every $100 that they lend. And this is a fairly standard charge. Usually it's like plus or minus $3 within this range. So let's say the term of the loan is 14 days. What that means is, as soon as you borrow the money, you must pay it back in 2 weeks. Okay, you need to borrow $400. They're going to charge you $22.50 for every $100 you pay. For every $100 you take out. Therefore, the amount of interest you will pay is 4 times $22.50, which is $90. So what does that mean? You're going to borrow $400 from them. You, of course, must pay that $400 back, right? They're going to give you $400. You must give them $400 back. On top of that, you will pay them $90. So they're going to write you a check for $400. In 2 weeks, you're going to come back and give them a check for $490. That's how this works. What's the APR on this loan? Well, let's use this formula from your book. If you ever want to calculate the amount of interest on something, particularly on a simple interest loan, the amount of interest is simply the amount of principal times the interest rate as a decimal times the amount of time in years. So way back up here in this formula, where to go? Okay, notice that F is P plus PRT. So if I just put this P inside, that's what it is, P plus a PRT. The P is the amount you take out. The PRT is the amount you must pay in interest. So the future value of something is always the principal plus the interest. So the amount you borrowed plus the amount you now have to pay as a fee on top of that. So one way you can think of this formula is saying P plus PRT, where that PRT is the interest amount. So again, this is all in your book, but that's where this comes from. Interest is principal amount times the rate times the time in years. Well, we already know in this case that 90 is the interest, $400 is the principal. We don't know the APR. That's the question here. What is the interest rate on this loan? And we also know the time in years. So whenever you're doing this on your own, you can always assume a 365-day year. We're not going to deal with leap years. So 14 days, right, 2 weeks is 14 out of 365. So here's the equation you get with 3 out of the 4 things inserted. Well, 400 times 14 over 365 is 15.34. So we get this equation here, 90 is 15.34r. So we can just divide both sides of the equation by 15.34, and we get the number 5.87. Now, remember, this little r is the interest rate as a decimal, not as a percentage. If you want to write this now as a percentage, which is probably how you are comfortable thinking about things, remember you got to move the decimal point 2 spots to the right. So 5.87 is 587%. Okay, so the interest rate, the APR on this loan that this payday loan company is so nice to give you is 587%. So to go on your vacation, you're going to borrow at 600% essentially. Okay. Now, I don't know how familiar you are with loan terms, with APRs or whatever. I don't know if you've ever taken out a loan, but let me just tell you, this number is absurdly high. It's like a joke. Okay, so my house, my mortgage loan, my interest rate is 4.125%. My auto loan, the loan on my car, the APR is 1.89%. Most credit cards, the APR is somewhere between 18 and 26%. Okay? So notice all those numbers I just gave you are far smaller than even like 100%, right? And this is 6 times bigger than 100%. This is why payday loan companies are so controversial. Remember their argument here? Well, we have to charge a higher interest rate than normal because these people are risky. So the critics of these companies, come back to them and say, let me just go back to the slide here. They come back and say, okay, you're not just charging higher than normal, you are charging like 30 times higher than normal. You are being predatory and you are preying on people's ignorance. So again, I don't come down on one side or the other, but it is not controversial to say that 587% is just astronomical. But it's fairly typical for payday loans. You'll commonly see APRs between 300 and 600%. Okay, so the global point of this example was to think about if somebody gives you 3 out of the 4 variables in an equation like this, you can always just substitute in what you know and then find what you don't know. That's what we did. We didn't know what the APR was, but we did know all the other numbers, and so we just plugged them in. So the last thing I'll say is, from this section, there are 2 equations you should know. This I equals PRT is one of them, the interest formula. The other one is this one, the formula that relates the future value and the present value at simple interest. Okay, so at simple interest, the future value is the principal times the quantity, 1 plus time in years, times APR as a decimal. Now, when we move on to section 10.3, simple interest will be changed to compound interest, and this formula will change. So this formula only works for simple interest. Okay, and so we are now done with section 10.2.